NENOMATICA, where mathematics meets YouTube excellence. Welcome to this math video where we'll be looking at some algebraic expressions and understanding how to expand and simplify them. Let's start with our first example. Let's look at this first expression. We have a product of two factors, a plus b plus c, multiplied by a squared plus b squared plus c squared minus ab minus ac minus bc. To expand this expression, we'll use the distributive property. We'll multiply each term in the first factor by each term in the second factor. Let's start by distributing the a from the first factor. We get a times a squared plus a times b squared plus a times c squared plus a times negative ab plus a times negative ac plus a times negative bc. Now, let's distribute the b from the first factor. We get b times a squared plus b times b squared plus b times c squared plus b times negative ab plus b times negative ac plus b times negative bc. Finally, let's distribute the c from the first factor. We get c times a squared plus c times b squared plus c times c squared plus c times negative ab plus c times negative ac plus c times negative bc. Now, let's simplify this expansion by multiplying each pair of terms. This gives us a cubed plus ab squared plus ac squared minus a squared b minus a squared c minus abc plus ba squared plus b cubed plus bc squared minus ab squared minus abc minus b squared c plus c a squared plus c b squared plus c cubed minus abc minus ac squared minus bc squared. Let's rearrange and combine like terms. We collect a cubed, b cubed, and c cubed terms. We also group terms that cancel out, such as ab squared minus ab squared, ac squared minus ac squared, and similarly for other pairs of terms. We have three abc terms with negative signs, which gives us negative 3 abc. After canceling the terms that sum to 0 and combining the negative abc terms, we get our final result, a cubed plus b cubed plus c cubed minus 3 abc. Now, let's look at our second example. We have the expression x plus 2 times the quantity 3x squared minus 1 minus the quantity 2x minus 1 times the quantity 3x plus 2. Let's work on this step by step. First, let's expand 2 times the quantity 3x squared minus 1. Using the distributive property, we get 6x squared minus 2. Now, let's expand the product of 2x minus 1 and 3x plus 2. Using the FOIL method, which stands for first, outer, inner, last, we multiply. First terms, 2x times 3x gives 6x squared. Outer terms, 2x times 2 gives 4x. Inner terms, negative 1 times 3x gives negative 3x. Last terms, negative 1 times 2 gives negative 2. Combining these, we get 6x squared plus 4x minus 3x minus 2, which simplifies to 6x squared plus x minus 2. Now, let's substitute this back into our original expression. We have x plus 6x squared minus 2 minus the quantity 6x squared plus x minus 2. Let's distribute the negative sign to the third term. This gives us x plus 6x squared minus 2 minus 6x squared minus x plus 2. Now, let's combine like terms. We have x minus x, which is 0, 6x squared minus 6x squared, which is also 0, and negative 2 plus 2, which is 0. So the entire expression simplifies to 0. Therefore, our final answer is 0. This means that the original expression is identically equal to 0 for all values of x. In this video, we've worked through two algebraic expressions. We want to simplify the expression, 2a to the 5th power minus 2 a times the square of the quantity a minus a times the quantity 1 minus a. Let's start by simplifying what's inside the square brackets. First, we'll expand the expression inside the parentheses. We have a minus a times the quantity 1 minus a. Let's distribute negative a. We get a plus negative a times 1 plus negative a times negative a. This gives us a minus a plus a squared. Now, let's simplify what's inside the square brackets. We'll combine like terms inside the brackets. A minus a equals 0, so we have a minus a plus a squared, which equals a squared. Now, we need to square the term inside the brackets. We'll use the power rule to simplify. A squared equals a to the 4th power. Next, we'll multiply what's outside the parentheses. We'll distribute the negative 2a. Negative 2 a times a to the 4th power equals negative 2a to the 5th power. Finally, we can combine like terms. Let's simplify to a to the fifth minus 2a to the fifth. 2a to the fifth minus 2a to the fifth equals 0. Now, let's move on to our second example. We want to simplify the expression 2 times the quantity 3 a minus 1 squared minus 3 times the quantity 2 a minus 1 squared minus 6 a squared. Let's expand the expressions with the squared terms first. We'll use the formula for the square of a binomial. For the first term, we have 2 times the square of 3 a minus 1. This means 2 times the quantity 3 a times 3 a plus 3 a times negative 1 plus negative 1 times 3 a plus negative 1 times negative 1. Now, let's expand the second squared term. We'll apply the same binomial square formula. For the second term, we have 3 times the square of 2 a minus 1. This means 3 times the quantity 2 a times 2 a plus 2 a times negative 1 plus negative 1 times 2 a plus negative 1 times negative 1. Now, let's distribute the coefficients outside the brackets. We'll use the distributive property. For the first term, 2 times 9 a squared minus 6 a plus 1 gives us 18 a squared minus 12 a plus 2. For the second term, negative 3 times 4 a squared minus 4 a plus 1 gives us negative 12 a squared plus 12 a minus 3. Now, let's group similar terms and simplify. We'll group all the a squared terms together, all the a terms together, and all the constant terms together. We have 18 a squared minus 12 a squared minus 6 a squared. That's 0 a squared. Then we have negative 12 a plus 12a, which is 0a. Finally, we have 2 minus 3, which is negative 1. Therefore, the final result of the second expression is negative 1. In this video, we've seen how to simplify complex algebraic expressions step by step. For the first expression, we expanded the inner terms simplified and found that it equals 0. For the second expression, we expanded the squared binomials, distributed the coefficients, combined like terms, and found that it equals negative 1. These techniques are essential for solving many types of algebra problems. We'll look at the step-by-step process of working through the following expression. 2 times the quantity 3 a minus 1 squared minus 3 times the quantity 2 a minus 1 squared minus 6 a squared. Let's begin our simplification process. First, we'll expand the perfect squares using the formula. The square of a binomial equals the product of the binomial with itself. So our expression becomes 2 times the product of 3 a minus 1 with itself minus 3 times the product of 2 a minus 1 with itself minus 6 a squared. Next, we'll use the FOIL method to expand each of the binomial products. The FOIL method stands for first, outer, inner, last, which helps us multiply two binomials together systematically. When we apply this method, we get 2 times the quantity 3 a times 3 a plus 3 a times negative 1 plus negative 1 times 3 a plus negative 1 times negative 1 minus 3 times the quantity 2 a times 2 a plus 2 a times negative 1 plus negative 1 times 2 a plus negative 1 times negative 1 minus 6 a squared. Now, let's perform the multiplications within each part. We'll apply the basic algebraic operations to simplify the terms. This gives us 2 times the quantity 9 a squared minus 3 a minus 3 a plus 1 minus 3 times the quantity 4 squared minus 2 a minus 2 a plus 1 minus 6 a squared. Let's now combine like terms within each parenthesis. We'll add or subtract similar terms to simplify the expressions further. This results in 2 times the quantity 9 a squared minus 6 a plus 1 minus 3 times the quantity 4 squared minus 4 a plus 1 minus 6 a squared. Next, we'll distribute the coefficients to each term in the parentheses. We'll apply the distributive property of multiplication over addition or subtraction. This gives us 18 a squared minus 12 a plus 2 minus 12 a squared plus 12 a minus 3 minus 6 a squared. Now, we'll rearrange and group like terms to simplify the expression further. We'll group all a squared terms, all a terms, and all constant terms. This gives us 18 a squared minus 12 a squared minus 6 a squared, plus negative 12 a plus 12a, plus 2 minus 3. Finally, we'll combine all like terms to reach our simplified answer. We'll add or subtract the coefficients of like terms. The a squared terms combine to give 0, the a terms also sum to 0, and the constants simplify to negative 1. Therefore, our final answer is negative 1. We want to expand and simplify the expression. 2a to the fourth power minus 2 times the quantity a minus b times the quantity a cubed plus a squared b plus ab squared plus b cubed. The first thing we need to do is distribute the terms inside the second parentheses. We'll apply the distributive property, which tells us that when we multiply a sum by another term, we multiply each term in the sum by that term. Now, we'll multiply each term inside the brackets. When we multiply terms with exponents, we add the exponents for the same base. For instance, a times a cubed gives us a to the fourth power. And when we multiply a by a squared b, we get a cubed b. Now we can simplify by combining like terms inside the parentheses. Notice that a squared b squared appears twice with opposite signs, so they cancel out. Similarly, ab cubed appears twice with opposite signs, so they also cancel out. A cubed b appears with different signs, so we get negative a cubed b. This gives us a simplified expression of a to the fourth power minus b to the fourth power. Now, we'll distribute the negative 2 to the terms inside the parentheses. Negative 2 times a to the fourth power gives us negative 2a to the fourth power. And negative 2 times negative b to the fourth power gives us positive 2b to the fourth power. In our final step, we combine like terms to simplify the expression further. 2a to the fourth power minus 2a to the fourth power equals 0, leaving us with just 2b to the fourth power as our final answer. Let's move on to our second example. We want to expand the expression, the product of 2x plus 3, 3x plus 4, and 3x minus 5. We'll start by multiplying the first two factors, 2x plus 3 and 3x plus 4. We can use the FOIL method or distribute each term in the first expression to each term in the second expression. Let's simplify the expressions in the brackets. 2x times 3x gives us 6x squared. 2x times 4 gives us 8x. 3 times 3x gives us 9x. And 3 times 4 gives us 12. Adding these terms, we get 6x squared plus 17x plus 12. Now, we'll multiply this expression by 3x minus 5. We distribute each term in the first expression to each term in the second expression. 6x squared times 3x gives us 18x cubed. 6x squared times negative 5 gives us negative 30x squared. 17x times 3x gives us 51x squared. 17x times negative 5 gives us negative 85x. 12 times 3x gives us 36x. And 12 times negative 5 gives us negative 60. Let's combine like terms in our expression. Negative 30x squared plus 51x squared equals 21x squared. Negative 85x plus 36x equals negative 49x. So our final result is 18x cubed plus 21x squared minus 49x minus 60. We need to simplify the expression. 2a to the fourth power minus 2 times the quantity a minus b times the quantity a cubed plus a squared b plus ab squared plus b cubed. Let's start by applying the distributive property. We need to distribute a minus b across the second factor. The first term stays the same as 2a to the fourth. We now multiply a by each term in the second parentheses, and then multiply negative b by each term in the second parentheses. Now, let's multiply each of these terms. We'll use the exponent product rule to combine like terms. When we multiply a by a cubed, we get a to the fourth power. When we multiply a by a squared b, we get a cubed b. When we multiply a by ab squared, we get a squared b squared. When we multiply a by b cubed, we get ab cubed. Similarly, when we multiply negative b by a cubed, we get negative ba cubed or negative a cubed b. When we multiply negative b by a squared b, we get negative a squared b squared. When we multiply negative b by ab squared, we get negative ab cubed. And finally, when we multiply negative b by b cubed, we get negative b to the fourth power. Next, let's combine like terms within the parentheses. We need to simplify by combining terms with identical variables and exponents. Notice that a cubed b appears twice, but with opposite signs, so they cancel out. Similarly, a squared b squared appears twice with opposite signs, so they also cancel out. The same applies to ab cubed. They cancel each other out. So we're left with a to the fourth power minus b to the fourth power inside the parentheses. Now, we need to distribute the negative 2 to each term inside the parentheses. We'll again use the distributive property. When we distribute negative 2, we get negative 2a to the fourth power plus 2b to the fourth power. In our final step, we'll combine like terms in the overall expression. We combine terms with the same variables and exponents. We have 2a to the fourth power minus 2a to the fourth power, which equals 0. So our final simplified expression is 2b to the fourth power. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.